Hello buddies, in this particular video I will be discussing NFV functionality. I would recommend you people should watch my previous video where I have discussed NFV concepts and architecture. Before I dive into this particular topic, I would discuss or introduce or give you the basic introduction about the NFV. So just look at this particular diagram. I have also discussed this particular diagram in the previous video. So NFV is a concept like you have got this traditional network application development where people have got this numerous amounts of or to like many types of hardware devices, and so to support the modern networking requirement we cannot actually deploy this many hardware requirement or hardware devices into the network. So what we can actually do, we all know these particular hardware devices are actually has been developed for a particular functionality, like you can say for a firewall, or you can say intrusion detection system, or you can say for the routing purpose, for the switching purpose, etc. So all this particular functionality can be get implemented in the terms of function, and that particular function or the code of that particular function can deploy in the virtual machines, and we call it VNF, that is virtual network functions. So all this particular functionality will actually get deployed on a single machine where the virtualization concept can be used to implement all these things. That's the concept of NFV actually is. In the previous video also discussed the high level NFV framework. You will have to generally remember this particular diagram everywhere because they have always taken this, and I will also be taking the same reference of this diagram to explain other further diagrams. So here we have got the three domains, that is virtual network functions and NFV infrastructure, NFVI, that is, and NFV management and orchestration. In small way I can explain you that here your infrastructure resides, your computing purpose, the computing things resides, your hardware things reside here, and accordingly using the virtualization layer you create virtual machines here with different network functionality, and all this thing can be done by using this particular model which we call NFV management and orchestration. So this was a short introduction about the high level NFV framework. I hope you understood. Now we can go ahead. So this is the index, and these are the four topics I will be discussing in this particular video in detail. So the first thing is NFV infrastructure. Let me show you the diagram. In this diagram they have circled it out. So basically in NFVI, if you remember in the previous slide only I have shown you the NFVI. You can pause or you can go back in the video, you can see that particular slide again. So there was a NFVI domain. So in NFVI domain basically there are three subdomains. So here the names are mentioned, that is, one is hypervisor, second is compute, and third is infrastructure. So what the purpose of this particular domains are, the heart of NFV architecture is nothing but a collection of resources. You should remember this thing, resources and functions. The NFVI encompasses three domains as here illustrated. The first thing is compute domain, that provides commercial off-the-shelf high volume servers and storage, that means servers and storage for the computing purpose. Second is hypervisor domain, that is mediates the resources of the compute domain to the virtual machines, means this particular domain is responsible, hypervisor domain is responsible for bringing hardware device into the virtual thing. And the third is infrastructure network domain, that is comprises of all the generic high volume switches interconnected into a network that can be configured to supply what, the infrastructure services. So this particular domain is required for the network thing, this domain is required for the virtual thing, and this domain is nothing but a computation purpose. Fine. So in NFA we have got three domains. Let's proceed. Before we proceed, before we move ahead, we should also understand the concept of container interface. Basically there are two types of interface. Container interface should not be confused with the container. I should make this particular note here itself, because in the previous video we actually understand the concept of container virtualization, but that was totally different. Container interface is totally different. See, here we have got two types of interfaces. One is functional block interface and second is container interface. So let me explain first functional block interface. I have not mentioned here the point, but you have to just understand and listen carefully. An interface between two blocks of software. When two softwares actually communicate with each other, that's nothing but a functional block interface. They actually call each other's functions, so we can call it functional block interface. People also call it API, that is application programming interface. And container interface is nothing but an execution environment on the host system within which a function block executes. So where you provide the actual environment where the function block executes is nothing but a container interface. It's like you providing a container where your application will get execute. Fine. So this is nothing but a container interface. The concept of container interface is important because where in the further slides we'll be discussing virtual machines and virtual network functions. You should understand like how the NFV architecture works there. So this is what we container interface. So just look at this particular diagram now. Okay, I will be explaining each and every point. Here we have got, as you can see, the bidirectional arrows 1, 2, 3, 4, 5, 6, 7 till 14. Okay, and also you can match this particular diagram with the NFV architecture I have mentioned in the start of this particular video. So we have got infrastructure network domain, hypervisor domain, compute domain. This is the NFVI window. Second was the management, that is Mano. Okay, orchestration domain, and this is nothing but NFV application. We create the virtual network functions. So in detail we'll be discussing, but you people have to just understand this particular tray. You can see NFVI container interface, virtual network container interface, virtual machine container interface. So I'll be explaining this particular interfaces. What does it mean? They act in simple way that this particular domain provide the container, so this particular applications can run on this particular container. In simple way I can frame it. So let's go ahead with this thing. So before I explain all the 14 bidirectional points I have mentioned in that particular diagram, you should remember certain points. The architecture of the virtual network function is separated from the architecture hosting the virtual network functions. Exactly. So NFVI and virtual network function is totally different. In the architecture they have shown that VNF is separate and NFVI is separate. The architecture of VNFs may be divided into number of domains then, with the consequence of the NFVI and the vice versa. Given the current technology, you will also have seen in that particular diagram that industrial structure compute, that is storage, hypervisor, and infrastructure networking are already largely separated domains. So they have separated, that is totally different domains. Management and orchestration, as we saw in that particular slide, I will again showing that particular slide again. Mano on the right hand side, that management and orchestration tends to be sufficiently distinct from the NFVI. NFVI totally works in different way. Mano works totally in different way. Two separate domains. They actually communicate with each other, but they work totally in different way. The interface between the VNF domains and the NFVI is a nothing but a container interface as shown you. So that was a tray that they provide. So where the VNF actually will get executed. So the container interface definition goes like this. I have mentioned that it provides nothing but an execution environment on the host system within which the function block actually executes. The management and orchestration function are also likely to be hosted in the NFVI as virtual machine if possible. So you can also have the separate domain, but if you want to have that particular functionality in the virtual term, again you can use the concept of NFVI and virtual all this particular functionality. So Mano will not be a separate domain. You will actually implement that particular functionality in virtual machine and host it as a VNF, that is virtual network functions. So coming back to this diagram, I will be explaining each and every point. So let's start with this thing. As you all can see the arrows. So one by one I will go. You can see the arrow number 1 here. This is an interface between the VNF and the existing network. So whatever the existing network and where the VNF is actually running, so there will be an interface here. Second, here, management of VNS by existing management systems. So existing management system will be managing all the VNF through this particular interface. Then third, where is third? Here. So all interfaces between this particular interface is acting as an interface between the VNFs. So it can be like interrelated. Okay, so VNF will be communicating with each other. Then fourth, you can see here that is a NFVI container interface. This is the primary interface provided by the infrastructure to host what? VNFs. Then fifth here, management of the NFV infrastructure by the existing management system. Basically we know that management and orchestration is responsible by this particular domain. So this is the interface where you will be managing. Then sixth here, virtual network container interface, that is the interface to connectivity service provided by the infrastructure. So how the service will get provided by the infrastructure to this particular interface will be provided by this particular interface, that is virtual network container interface. Seventh, this thing, that is virtual machine container interface, primary hosting interface on which VNF or VMs runs. So all this particular machine runs on this particular container interface, virtual machine container interface. And eighth, this thing, this arrow. Interface that allows the VNF to request different resources. If they are asking or seeking for the resources, they can actually contact man domain and pull out the resources with the permission of, but of course, man only. This is the interface where they can actually communicate. Then ninth, where is the ninth here? So Mano will be actually communicating with this infrastructure network domain. So management and orchestration interface with the this particular interface. So if this particular VNF asks for the resources, so this particular domain will actually contact this network domain to provide infrastructure to virtual network functions. 9, and this is the 10th. Again, if Mano wants to communicate with the hypervisor domain, this is the 10th interface. Similarly, if Mano wants to communicate with the compute domain, there is an 11th number interface. And how the compute domain provide the interface to the hypervisor domain computation way. So it provides a container interface called compute container interface. And the 13th one is like how the infrastructure network domain actually compute or connect or interface with the existing network. This particular interface called 13, and how the infrastructure network domain is communicating compute domain 14. So actually you can see it's totally a complex way to understand, but if you go one by one to understand how this particular things work, it becomes easy. Fine. So let's move ahead. Next topic is deployment of NFV containers. So just look at this particular diagram. We have got two parts, part A and part B. I will be explaining first part A1, that is part A. A single compute or network host can host a single compute node, as you can see here, or network host can host multiple virtual machines. You can see multiple virtual machines, multiple virtual machines. We have got multiple virtual machine container interfaces. So each of which can host a single VNF, as you all can see here. So the single VNF hosted on a virtual machine is referred to as a VNF component, VNFC. So this is what you call single compute platform supporting multiple VNFC. Means on a single machine you are actually hosting multiple virtual network functions component. Fine. One more way we can actually achieve the deployment on an NFVI. A second is this thing. You can easily relate. Here we have got multiple compute platforms, and on multiple compute platforms you can have multiple virtual network container interface, and accordingly you are building single NFVI container interface where the multiple virtual network function components are actually interacting with each other, forming a single VNF. It can happen because you can understand the four functionality can, if work together, they can actually it's a single process. What you call is a single process. So VNF is hosted across the multiple compute platforms. So single VNF is actually, we want to process for that particular VNF, we want 4 components, and that all those 4 components are actually distributed on the different platforms. This will compose distributed VNF hosted across multiple compute platforms. Next, what we call compute domain. So we have seen in that particular diagram where we have got 3 domains: hypervisor domain, compute domain, and the management domain. So in the compute domain, the principal elements in typical compute are CPU memory. What it means you all know, with the main memory. Then second is internal storage, that is non-volatile storage housed in same physical structure as a processor. And third is accelerator. You all know accelerator functions for security, networking, and packet processing. Then fourth is external storage with some storage controller, that is access to some secondary memory devices. And fifth is network interface card that provides the physical interconnection with the infrastructure domain. Sixth is control and admin agent that connects the virtual infrastructure management, short form is VIM. I will be discussing VIM in detail in the further slides. So it's nothing but connects the VIM with the NFV concepts and architecture actually. So that's an agent, acting as an agent. Then E-switch, that is server embedded switch. The E-switch function described in the is implemented in the compute domain. Functionality is like forms the integral part of the infrastructure. It's like it used for the switching purpose. Eighth, that is compute storage, and the last is the compute storage in the execution environment. This is the execution environment where the presented hypervisor software resides, and actually virtual machine can be created, you can say, compute domain. Fine. So next is NFVI implementation using the compute domain nodes. There are 4 types of nodes. One is compute nodes. As the word suggests, the functional compute node is nothing but a functional entity which is capable of executing a generic computational instruction set. in such a way that execution cycle time is of the order of the units of the tens of nanoseconds. It executes so fast, like in the terms of nanoseconds. So compute node is for the purpose of computation nodes. Gateway nodes, as the name suggests, gateway, a single identifiable, addressable and manageable element within NFVI node that implements the gateway function. So where the from where the instruction will come and go, you can say a path. So that will be a gateway node. Third is storage node. This node, again a single identifiable, addressable and manageable element with NFVI node that provide what? The storage resource using for compute, storage and networking functions. And the last one is network node, a single identifiable, addressable and manageable element with NFVI node that provides what? Nothing but networking, like switching and routing concepts. So these four nodes can be actually implemented in the compute domain: compute, gateway, storage and network node. Next is hypervisor domain. In hypervisor domain, software environment that abstracts the hardware and implement the services in terms of actually virtual. Starting a virtual machine, terminating a virtual machine, acting a policy, scaling, live migration and high availability, all this thing can be actually done through hypervisor domain. So actually the principal elements are, I have listed here. The first is compute, storage, resource sharing management, as the word suggests, that manages resources and provides a virtualized resource access on the virtual machines. Second is network resource sharing management, manage this resource and provide the virtualized resource access. It provides the access, as the word says, networks will provide the access over the network for the virtual machines. Third is virtual machine management, as a name suggests, like for using how the virtual machine will get managed. So this particular thing we can use. Then again we have got the control and admin agent for the hypervisor domain. Same thing we have got for the compute domain we saw. So it connects to the virtualized infrastructure manager (VIM). And here in the previous slide we have got eSwitch. For this thing, for the compute domain, we have got here vSwitch. That vSwitch function is describes in the is implemented in the hypervisor domain for the virtual switch. It's forming a virtual way. Okay. And the third domain was infrastructure network domain. That is, this domain performs a number of roles I have listed here. So let's go through it very quickly. That it provides a communication channel between the VNFC, that's the virtual network function component, communication channel between the different virtual network function, communication channel between virtual network function and their orchestration and management manner, communication channel between components. We saw the diagram, if you remember, that 1 to 14 I have listed here, that numbers were mentioned, that particular manner is responsible for managing and actually having an interface with so many domains. So this means that means of the remote deployment of virtual network function component, the means of interconnection with the existing carrier network. So this particular domain is actually totally responsible for having a network or a channel or communication between all these particular modules. Second things we have to discuss, the second point of this particular video is virtualized network function. So just have a look at this particular table. So virtual network function is nothing but, let me again define it in a simple way. See, you have got so many functionality in implementing networking. We are in the era of modern networking where the demand is very huge and data is very huge. And again, the providers, or you can say the users, are increasing day by day. So how to support this massive amount of networking can be actually achieved by through two technologies. One is NFV and second is SDN. In NFV, we studied virtual network functions. Means you have got so many devices in physical way, you can deploy all those devices and you can achieve the modern networking. But again, there are certain consequences of using physical hardware. So what you can do, you can actually save the time, cost, space, and you can actually implement all those functionality in the virtual way. So you can create the virtual machine and code that particular functionality in that virtual machine. So what happens in the single physical machine, we can run multiple virtual machines. So by a single physical machine, we can actually achieve multiple network functionality in a virtualization way. So this is what we call virtualized network functions. So here in this particular slide, as you all can see, functions that are listed and how the network elements get used. So all these particular functions actually get implemented through VNF, that is virtual network functions. You can pause the video and can just go through it. I can discuss one of There's few, that is if you want to implement the firewalls, virus scanners, intrusion detection systems, spam protection. So all this thing or all these network elements, you cannot actually buy the hardware devices to implement. You can just implement all these terms in the coding or function way, and all these particular things will get implemented in the virtual machines. So that will form the virtual network functions. So let's proceed now. So there is something called VNF interfaces. How the VNF actually interact with each like other VNF. So here we have got 5 types of interface, that is SWA 1 to 5, as you all can see here. See 1, 2, 3, 4 and 5. So what one by one I will be discussing. See SWA 1 here. This interface enables communication between VNF and other VNF and the endpoints. Okay, so this particular interface is responsible for that. SWA 2, this interface enables communication between VNFC. If single VNF have got the multiple VNF components, so if that multiple VNF components want to interact with each other, so they have to use this particular interface, that is SWA 2. Then we have got SWA 3. This interface is for the manager actually. Yeah, okay, it is used to interact with the manager, VNF manager. As we have said it, that we have got NFV management and orchestration manual module, which is used to manage the VNFs. So that particular interface will be used for that managing purpose. Then we have got SWA 4. This is the interface for the runtime management of the VNF by the element manager. We have got every VNF has got the element manager to manage. So this particular interface for the element manager, and we have got SWA 5, that is to interact with the NFV, that is network function virtualization infrastructure we saw before. Okay, so we have got 5 interfaces in the VNF interfaces, SWA 1 to 5. Okay, next, VNFC to VNFC communication. How VNF component actually communicate with the another VNF component we have to see. So we have got generally 6 scenarios here. So I will be explaining each scenario one by one. You just have to pay attention. See the scenario number 1. Okay, so we have got one VNF, and in one VNF, I'm just telling for the example sake, like in a single VNF we have got two VNF components. So how they communicate. So in the scenario 1, communication through hardware switch. See, as you all can see. In this case, the virtual machine supporting the VNFC bypass the hypervisor. So this is how they can communicate. In the second scenario, communication through the V switch, that is virtual switch, and virtual switch is provided by the whom? The hypervisor layer. In the scenario number 3, the greater performance can be achieved by using the appropriate, you can see here DPDK, that is nothing but data processing acceleration libraries. The full form is nothing but data plane development kit, and which will accelerate the performance between the communication of the VNFC. Okay, this is the third scenario. The fourth scenario is like communication through an embedded switch, actual physical switch, you can say. Here we have got the virtual switch, but here we have got the actual physical switch, embedded switch, deployed in the network interface card. Okay, so this SRIOV, you can see, that means that single root input output virtualization, which is again used for some optimization purpose. Then fifth scenario here, again embedded switch, but again using this particular toolkit we mentioned, as I mentioned before. Here also, say DPDK. And the last scenario, that is scenario number 6, is nothing but a serial bus we want. Serial bus connects directly to VNFC. So these are the 6 scenarios of connecting the VNFC to VNFC. Okay. Next thing we have to study is VNF scaling. It's like how to grow it or how can you can remove it. Okay, so an important property of VNF is referred to as elasticity, you can say, which simply means the ability to scale up, scale out, or scale in. Every VNF has associated with it elasticity parameter, whether they can be scale up or scale down, whether they can be scale out or scale in. What do you mean by scale up and scale out? Here I have mentioned scale up is something but expand the capability by adding additional physical machines or virtual machines. Okay, so if you are adding physical or virtual machine, so that means you are expanding the capability. That means scale up. You are scaling up. What do you mean by scale out is nothing but expand the capability of single physical machine or virtual machine. So if you are actually extending the capability of single physical machine or single virtual machine, so that means scale out. Okay. Third thing we have to discuss here is nothing but NFV management and orchestration, that is manual. Okay. So before I go to the diagram, I want to mention some points here. So the NFV management and orchestration component of NFV has a primary function that but of course it's to manage and orchestration of the NF environment. And I've mentioned here the further complicating manner functionality is it to need to interoperate with the cooperate with the existing operation. I've mentioned there is certain domains called OSS and BSS, that is operation support system and business support system. So manage is also responsible for communicating or having an interface with these particular systems. So basically, so user will operate from here, so they will be also able to communicate with the manner functionality or customize it. So again, I have mentioned here. So let's proceed with this particular diagram. So you just have to focus on the boxes here. We have got OSS, BSS, we have got here VNF along with element management system, and we know all this. We know what NFVI is, that is the infrastructure where the whole infrastructure resides. This is the complete manner system. In this also we have got three boxes. That one is NFV orchestrator, VNF manager, and VM. I've also mentioned this before. I've told you basically I will be discussing this thing in detail now. So let's discuss this particular component. This is the diagram. This the NFV manual architectural frameworks with reference points. So these are the reference points. So let's go ahead discussing all these things. So first thing is VM, virtualized infrastructure manager. Sorry. So virtualized infrastructure manager comprises the functions that are used to control and manage the interaction of VNF. Very simple to understand, with the computing facility, storage facility, and network resources under its authority. So you just have to understand, you can have a single instance of VM who is responsible for managing multiple VNFs, or you can have multiple instances of virtual machine infrastructure manager VMs. Okay, so VMs perform what actually VM is responsible is VM, in simple way, VM is responsible for inventory of softwares, allocation of virtualization enablers, or management of the whole infrastructure resource and allocations, you can say. So there, that was VM. So coming back to this, now we will switch to that is VNF manager, VNFM. So VNFM performs the following. So let's see that this particular module or particular domain is responsible for VNF instantiation, that it creates the VNF, builds it. Initial configuration can be done through this module, and VNF instantiation feasibility checking if required, software update, upgrade, modification can be done by this particular thing, and scaling out, scaling up and down can be done by this particular module. This particular module is responsible for that. Coming back to the diagram, so this thing is done, this thing is done. Now NFV orchestrator, you just have to pay attention here. These are the four, we can say, repositories along with this particular model, that is NFV orchestrator, NFVO. So what is NFV orchestrator? This is responsible for resource orchestration and network services, as the name suggests, and resource orchestration manages and coordinates the resource under the management of different virtual infrastructure management VIMs. So all the management or allocation will be done through this particular model, that is NFV orchestrator, and it has got four types of repositories. One is network service catalog, that means it has the list of all the usable network services. Okay. Second is VNF catalog, that means database of all usable VNF descriptor, that means VNF descriptor means describe the VNFs. So what VNF you have got, so if you want to see how many VNFs you have got with the description, you can go for the VNF catalog. Third, that is NFV instances, that means list containing details about the network services instance related VNF instances. Okay. And last is NFVI resources, that means list of NFVI resources, that is infrastructure you have got, the storage system, okay, the you can say computing systems and all, etc. So we have all the resources will be listed here in this repository. Fine. Okay. So far we have discussed this VM, VNF manager, and NFV orchestrator, and all these four repositories. So now next thing we have to discuss is nothing but element management system. See this thing. So element management system is responsible for fault configuration, accounting, performance, and security. Short form is FCAPS, management functionality for the VNF. So whole the VNF can get managed by the element management system. So how it can manage? It can manage fault configuration, accounting, performance, and security. So EM includes all this thing, and the next thing we have to go for this thing, OSS and BSS. So in simple we have given here The OSs, BSS are the combination of operators, other operations, and business support function with what they are seeking for this. Why we are actually building the modern networking capacity or capability using VNF. So you will be interacting through this particular thing, and they will be demanding such a requirement, and that requirement can get fulfilled through NFV Mano architectural framework. Fine. So this is the OSs and BSS. And the last thing which we have to discuss in this particular video is NFV use case. Actually, there are 9, and all those 9 use cases actually can further divide into 2 categories. One is architectural use case, and second is service oriented use case. What do you mean use case? You just have to understand the simple thing that NFV technology or network function virtualization can get used in these particular areas, in this particular 9 areas where we have got different scenarios, okay, requirement you can say. So in this particular 9 different scenarios or 9 cases, 9 use cases where we can use the NFV. So we'll be discussing this 9 use cases one by one. So we'll go through it very quickly. So first one is NFV as a service. It actually same as cloud infrastructure as a service, when you provide the network function virtualization infrastructure as a service. So here it is mentioned is a scenario in which service provider implements and deploys the NFV that may be used to support virtual network functions. So if you need virtual network function, you can actually contact the provider of NFVI, where you can actually host your own VNFs. Second, VNF as a service you can compare with the SaaS, as I have mentioned. The software is ready as a service available on the cloud. Similarly, virtual network function have been made and actually already implemented. They are actually available as a service, so you can use it. So VNF as a service. Third, that is virtual network platform as a service. You can again compare it with the PaaS, that is platform as a service, where the cloud provider make the platform ready. Here you can make the virtual network platform ready. So basically people can come and create their own customs VNFs for the use actually. Fourth, that is VNF forwarding graphs, that is short form is FG, allows the virtual appliances to be chained together in flexible manner. I have mentioned the simple example here. It is also called as service chaining. Suppose for example, a flow we want to pass through first by network monitoring virtual network function, means whenever something comes, it will go to the first VNF, that is network monitoring, means monitoring will be done, and then second by load balancing virtual network function, and then finally by firewall. So this is what we call forwarding graph you decide. So VNF forwarding graphs. Fifth, this is the criteria or category under service oriented use cases. Okay, the previous 4 were under architectural use cases. Now from the 5th onward, we will be discussing under service oriented use cases. So the first thing is virtualization of mobile core network and IP multimedia system. So you all know that NFV aims at reducing what? The network complexity and related operational issues by leveraging standard IT virtualization technology to consolidate different types of network equipment onto the industry standard. So as we are aware, mobile cellular networks have evolved to contain a variety of interconnected network functions element. So all this thing actually can get implemented through NFV. 6. That is virtualization of mobile base station. The focus of this use case is like radio access network. Here I have mentioned RAN, that means radio access network equipment in the mobile networks. So RAN is nothing but a part of telecommunication system that implements the wireless technology to access the core network of the mobile network services. So there is a possibility that a number of RAN functions can be actually also virtualized through VNFs using the NFV technologies. 7. Virtualization of the home environment. See, this use case deal with the network provider equipment located at the customer premises, like the CPE equipments. Like it may include residential gateway for the internet or voice over IP or set-top box for the media service normally. So all this particular functionality can get actually implemented through NFV technologies. 8th, that is virtualization of content delivery networks. See, delivery of content, especially of video. Let me discuss this. Especially of video is one of the major challenge of all the operator networks because of the massive growing amount of traffic to be delivered to the end customer on the network. So some internet service providers I have mentioned here are deploying the proprietary content delivery network cache nodes in the network to improve the delivery of video. And you just understand that this particular again functionality can get implemented in VNF. See, yeah, I mentioned that all the CDN cache node or CDN controller can actually potentially be virtualized. So you can use the NFV technology and you can use and you can compute or you can code this particular functionality in virtual machines. Okay, and build your own VNF. And the last one is fixed access network function virtualization. See, NFV offers the potential to virtualize remote function in the hybrid or fiber or copper access network and passive optical fiber cable to the home. But this use case has the potential for cost savings. See, benefit is that virtualization support multiple tenancy in which more than one organizational entity can either be allocated or given the direct control of a dedicated partition of the virtual access node. So basically, fixed access node for network function virtualization can make it like this particular network function is for the particular specific purpose, and you can achieve the result. So that's it from the video. So reference I have taken from this book. I hope you enjoy the video. Thank you so much.